Hi, welcome to another video. In this video we are going to solve reorder list problem from the Leetcode. In this problem they will give a linked list and they are asking us to group nodes based on some criteria. The criteria is we have to choose one node from the beginning and one node from the end, and this process continues until we finish considering all the nodes. Consider this first example where the given initial list is 1, 2, 3 and 4. So reordered list, when we reorder, 1 comes first and then the last node 4, and then we are going to continue the same thing, then 2 comes next and 3 from the last. So we are going to continue this process. Here also, even in the second examples, initially we have 1, 2, 3, 4 and 5, then they will keep on grouping these first and last nodes together. So initially first node is first 1 and last node is 5, so 1 and 5 are grouped, and then we have 2 and 4, then 2 and 4 comes next, and then we have a 3, then 3 comes next. So if we analyze this problem, one way to solve this is we can put all these numbers into a list or array, and then we can traverse from beginning, and we can keep 2 pointers, one to the starting of the array and one to the end of the array, and then we can choose those numbers and we can keep on creating the nodes or node value. But here in the problem they have mentioned you may not modify the value in the nodes list, only nodes themselves have to be changed. So other way to look at this problem is what we can do is we can find the middle of the linked list and then we can reverse from there. So initially list is 1, 2, 3 and 4. From the middle we are going to reverse. So if we reverse it, it becomes from the middle 3, 4. If we reverse it, it becomes 4 and 3. And then we can merge this list by going through those lists. So this is the overall technique to this problem. I will explain this solution along with the example with the drawings as well. Let's go through some examples to understand how we are going to solve this problem. Consider this linked list where the nodes are 1, 2, 3 and 4. This list has even number of nodes. For even number of nodes, we have to decide what is the middle. So for finding the middle for even number of nodes is different from finding the middle for odd number of nodes. So let us consider this example where 1, 2, 3 and 4 is given, and we will declare 2 pointers, initially slow and fast. Both will point to the head of the list, and at each time we will move the slow pointer by 1 position and we will move the fast pointer by 2 positions. So slow will come to 2 and fast will come to 3 because we are moving fast pointer by 2 positions. So once it is done, we are going to continue this process. So the list is 1, 2, 3 and 4. Here when we move the slow will come to 3. But when we move the fast by 2 positions, it will move to the none pointer. So it will reach to the end of the list. So for even number of nodes, fast will reach to the end of the node first. So this is something that we have to keep in mind while going through the list when we have even number of nodes. And let us consider one more example where we have odd number of nodes. Given nodes are 1, 2 and 3, and we will follow a similar technique. Slow will also point to the first node and fast will also point to this first node. And when we move the slow by 1 position and fast by 2 positions, fast will reach to the 3. So here just observe our fast dot next has become none. So if there are odd number of nodes in the list, then fast dot next will become none. So this is something that we have to keep in mind. So how to decide the middle of the linked list? So once we have the middle of the linked list, then we have to split that list into 2 parts. So how are we going to split it up? So in order to split the list, we have to take care of 2 things. One is when we split the node, each list should end with a none pointer, otherwise we will be keep on iterating over the list. So we are splitting at 1 2, and the second list becomes 3 and 4. So we are splitting exactly at the middle. So our after 1 2 we should have a null pointer. So our in the iteration previous to slow will have a pointer to 2. We will declare a variable named previous, and previous dot next should be assigned none because initially it will be pointing to 3. So we don't want that. In order to split the list, we will assign it as none. And similarly we have to take care of this case in case of odd number of nodes as well. So here how are we going to split? Our first list will become 1 and 2, and our second list will become 3. So after 2 we have to, this is our second list, and after 2 it should point to a none pointer. So what is the 2? 2 is slow, and so slow dot next should become none. This is the thinking behind how are we splitting the nodes at the middle. Yes, if you observe here, slow dot next should be none because after 1 2 we should point to a null pointer, and before submitting that as none we have to store it in a separate value because second list head is also slow dot next. If we take care of these conditions while writing the solution, it becomes very easy to understand. So now we have split the whole linked list into two parts, first and the second part. And then once we have this first and second list, what we should do is we should reverse the second list. So reversing the lists is a separate problem in Leetcode. We can go through the technique as well, but overall understanding for reversing a linked list is we are going to just reverse the direction of those links. So initially we will have this list, we are just taking it as an example. If we want to reverse this list, we just have to reverse the links of the list. So currently 1 is pointing to 2, we just have to make it as reverse. So before to 1 there is no node, so 1 will point to none, and after that we just have to keep on continue this process. So our 2 should point to 1. Now this is overall approach for reversing the linked list. When we go through the code, you will understand this technique better. We are going to use a variable named previous which will be initialized to 1, and after that we will continue this process for other nodes as well for reversing a linked list. Finally what we are trying to do is we are going to reverse all the links of the lists, and then we will make 4 the final node as head. So this is the technique behind reversing a linked list. Once we reverse the linked list, then we have to merge those lists for reordering the list. So that merging technique we can understand, and before writing the code it will be easier. So now we have 2 nodes. Initially this is the given list 1 2 and 3, and let's say we have split the node at 1 2 3, and another list has 5 and 4 after reversing. And now L1 and L2 we are going to take 2 pointers L1 and L2. We know that we should start combining those things. So anyway L2 is already reversed, so we don't have to take care of anything else. We are going to store these nodes even before making any changes. Next node L1 and next node L2, we need these nodes for traversing the list. After this we are going to change L1 dot next equal to L2 because after 1 5 should come, and L2 dot next should be we should be careful here because L2 dot next we cannot write it as L1 dot next because it creates a loop. So we should make use of the variable which we have stored previously. So L2 dot next becomes next node of L1. So what happened here, what we have done is after 1 we are linking it to 5 and 5 will link to 2. So here we are assuming that L2 is already reversed. We have found the middle and we have reversed the list from the middle, and now we started combining this process, and after that we can assign L1 as next node of L1 because next node of L1 is still pointing to node 2 and L2 will be next node of L2. If we understand this diagram, then understanding we are just going to implement the same thing in the coding as well. So our L2 will become next node of L2 because next node of L2 is still pointing to node 4. Then we will keep on continue this process. Code for the discussed solution. What we are going to do is we are going to find the middle of the linked list, and then we are going to split the linked list into two parts, and then we are going to reverse the second part, and then we are going to merge those two things. So this is the approach that we have discussed. If you are thorough with that explanation, then following this code becomes very easy. Anyway, we will start writing the code for this solution. So first thing we have to do is finding the middle. Find the middle. What we are going to do is we are going to take two pointers as we have discussed. Slow equals head and fast will also be equal to head. Once we have these two nodes, then we will keep on going through the list as well as we have some valid nodes. While we are going to check the slow first and fast. Since we are going to move the fast by 2 positions, we are going to access the pointer after fast.next as well. So we have to check whether fast.next is a valid pointer or not. So what we are going to do is slow equals slow.next and fast equals fast.next.next. Here what we will do is we will keep another variable so that this can be used for splitting the list into two parts in case of even and odd. So once we start going through the list, we know that something happens based on the even or odd. If it is odd case, then fast.next becomes null. So if it is even, then fast itself will reach the none pointer. So then we will check if not fast. This happens when we have even number of nodes. Even number of nodes in list. So this condition becomes true, and what we should do, so we should split it here. So our slow is pointing to 3 now, and our previous dot next should become none. Previous dot next will become none, and our second list head, we will declare a pointer here for second list head. We are going to initialize it to none, and our second, if it is even, then we know that slow is pointing to 3. Then second list head will become slow. So we are doing this previous dot next equals to none because after splitting, it should end with this first part should end with a null pointer. So after 1 and 2, it should point to a null pointer. That's what we are trying to do here. So what happens if our linked list has an odd number of nodes? if it is odd number of nodes, and then our first dot next becomes none. So this is the case for here. So our slow will be pointing to 2, and what we should do is we should split it as 1, 2 and 3. So our second list head becomes slow dot next, and also at the same time we have to set the slow dot next to none. So our second list head becomes slow dot next, and we should also set this to none. So we have finding the middle, and then this is for odd number of node case, odd number of nodes, odd number of nodes in list. So this is, we are doing this to get the split linked list into 2 parts in the middle. So we are splitting the linked lists in the middle, then we have to reverse the second list. So we are going to reverse second part of the list. So what we are going to do is we are going to declare a previous pointer as none, and we will have a current pointer to a second list head. Then we will keep on going through the list. So while our we have a valid node that is current, what we should do is, before doing anything, we should store the next node. That is, next node will be equal to current dot next, because we will be modifying this pointer, and after modifying we need to move to the next node. So for that we are storing this value. So what we will do, now we have the next node, now we can modify this current dot next. Current dot next should point to the previous node. Initially previous will be none, which is valid for the first node, and then our current becomes previous. So our previous will be assigned to current, and what we should do, then we should move forward. So current will be equal to, we cannot do a current dot next because current dot next is pointing to previous node, so we should use this value which we have stored before. So it becomes next node. After doing all these things, we will have a we should update the head of the second list. So our second list head will become previous. So now we have reversed the second list. Now we should start merging those two lists. While we will assign these two things to L1 and L2 so that it becomes easier. L1 will be head and L2 will be equal to our second list head. Now we have these two variables. While we have valid nodes from both the lists, we can keep on merging while L1 and L2. And what we can do is, before doing anything, we will store the next node L1 and next node L2. Next node L1 will be L1 dot next, and next node L2 will be L2 dot next. Now we have these two values. What we should do is, now we will start merging those two things. So what we should do, since we have a, let us say this is reversed, our L1 dot next will point to the L2, and we should change the L2 dot next as well. So our L2 dot next we cannot assign it to L1 dot next because it creates a loop. So we should use this value, next node of L1. So whatever the code that we are writing is very similar to what I have explained in the solution. So if you go through the code along with that diagram, it becomes very easy to understand. So after this, we are going to move these things. So L1 will be next node of L1 and L2 will be next node of L2. So when there are odd number of nodes, we know that L1 has more nodes compared to L1 has more nodes compared to L2. So we will have a remaining node at the end of L1. So if that is the case, if L1, then we have to add L1 dot next should be equals to L1, and after that we can directly return the head of the list, that is L1 head. I think this solution works. Let us submit the solution and check whether it passes the initial test cases. This problem is a combination of 2-3 problems where we find the middle of the list, and we should know these things, how to find the middle of the list and how to split the list and how to reverse a linked list. If we know these things, then it becomes easier. Okay, it is showing error, found a cycle in the list node. Now we have to check where we are going wrong. Okay, what we can do is we will go through the solution again to understand whether we are doing something wrong. Okay, we are finding the middle of the linked list, and based on the odd and even case, we are doing these things. Second list head, and when it comes to previous, okay, we are reversing the list. Okay, second list head is updated, and here are we doing something wrong? That is the main question actually. Okay, we are storing these nodes, and after that, let us say we have two lists 1, 2 and 3, 4. L1 dot next becomes L2, that makes sense. L2 dot next becomes next node of L1. Okay, that is also correct. And after that, we are doing L1 equals next node of L1. Okay, I think this condition is not needed actually, because anyway we are taking care of all these things here. So I think let me remove this condition and check. Let us submit this solution again, because anyway even if the node remains, it will be in L1. It is already part of L1, so we don't have to create a loop in the end. I guess that is creating a node loop. Let us check whether this solution is passing. Yes, it is passing the initial test cases. Before submitting the solution, let us discuss about time and space complexity. For time complexity, here we are going through the list once to find out the middle of the linked list, and then we will go through half of the list to kind of find the reverse of the second part, and then we will go through again to find. So overall time complexity is O of, this is to find O of n for finding the middle of the list, and n by 2 for reversing that second part, and for n for merging those two things. So overall time complexity will become O of n, because we don't take care of any constant multipliers here. So time complexity is O of n. What is the space complexity? For space complexity, we are using some additional pointers here: slow, fast, second list, head, L1, L2, variables like this. But we are not really using any extra space which is going to scale with the input. So we have a constant space complexity. Let us submit this solution and check whether it passes all the test cases. It is taking some time to process. Maybe Leetcode is slow, I guess. Let me run this solution again and check. Okay, initial test cases are passing, but when I submit is also working. So this is the solution that we have submitted. First we will find the middle, and then we will split the list at the middle, and then we will reverse the second part, and then finally we are going to merge those two things. So if you want to understand, if you have some confusion regarding this solution, what you can do is you can go with the diagrams. So in the second part of the video I have explained with the diagram. Similarly, you can try to go through those things by yourself, so this solution becomes even more clear. If you are interested in learning more about other data structures and algorithms, you can check out other videos from my channel. Thanks for watching this video.